and y plus 10 equals 1/4 x plus 8. Remember that we care about the original equation and not this one, because yeah, we just use the slope-intercept form to help us with this one. Let us see. So our solution is 8, -6. So 8 goes here. -6 goes here. 8 goes here. I'll just put it like that. -6 goes here. I don't know why that's so. There it is. Okay. So y equals -3/4 times 8. And y plus 10 equals 1/4 times 8 plus 8. Okay, let's do the math. A negative times a positive is a negative. Well, I should write this first. -6 equals. Okay, a negative times a positive is a negative. 3 times 4 is 24. 24 divided by 4 is 6. Good. And let's go ahead and try this one. -6 plus 10 is -4. And then order of operations, 8 plus 8. So 1/4 times 6. Ooh. Something feels wrong. Oh, I know what I did wrong. -6 plus 10 is +4, not -4. And then 1/4 times 8 plus 8 is 1/4 times 16. And I don't know why that irritates me. Maybe that's better. Okay, 1/4 times 16. And then 1/4 times 16. 1 times 16 is 16. 16 divided by 4 is 4. Ooh. Sorry, I just try to make sure it's completely, well, not completely, but legible for the people that just look at the notes. So, and we have 2 more examples, but they go by like fairly quickly. All right, so this is example number 3. So we have y equals 2/3 x plus 4 and -6x plus 9y equals 36. So if you can tell, well, we'll make this one the reddish one, or the red one. And we will make the -6x plus 9y equals 36 will be blue. As you can see, well, it looks a little strange here, right? Because first you don't even see like both lines. Well, sort of. We'll get to that. If you can tell, I took this equation down here and I converted it to slope-intercept form. It was in a standard-ish form, but it wasn't in slope-intercept. So I added 6x to both sides, and I got 9y equals 6x plus 36. I divided by 9 right here. And I get y equals 6/9x plus 4. And then I reduce my numerator and denominator by 3, or divided each one by 3. And I got 2/3 x plus 4. Y equals 2/3 x plus 4. And I went ahead and, well, so I had these equations, had these 2, and then I converted one. If you notice though, y equals 2/3 x plus 4 came from this one, right? But it's actually the same as this one right here. Like, so I'm going to draw an arrow, and oh, I can do a tiny bit better, I think. So I guess we'll say start here. Start here. And then I convert it, same equation as this one. So we'll put same equation. Well, we'll just put same. So they're the same. That, like when I converted this and this original one, they're the same. So that's why you only see one sort of line-ish, but that's why both of these are here. Like y equals 2/3 x plus 4. I went 4 up 2 over 3, up 2 over 3, up 2 over 3. And then after I converted this one, I did the same exact thing. So they have the same exact solutions. That's why you only see one of the lines. I mean, both are sort of like right here. This is right here. Or those are the solutions to that equation. And those are the solutions to those equations. They're the same exact solutions. So let's go to our statements. Let's go to this third one. I kind of messed it up, but we'll be fine. So let's get rid of that and capitalize that. So they both have the same like slope, right? So the slopes, and they both have the y-intercept plus 4, right? Yeah, plus 4. The slopes and the y-intercepts are the same. So both equations, so both of these equations share the exact same solutions. Well, yeah, we'll say solutions. The exact same solutions. So if 3 comma 6 works for this one, 3 comma 6 works for that one also. And I can also say that there are an infinite amount of solutions. So under the proof, we don't have to like choose all of them, because we'd have to choose like all of them would be an infinite amount. Like we could never do that, right? So we wouldn't prove that one works for both, because then we'd have to prove, well, like theoretically, like all of them infinitely work for both. So an infinite amount of them work for both. So we will just say infinite, or we will just write infinite solutions. Infinite solutions. And we'll put in parentheses share, or we'll put they share. They share all of them. They share all the same solutions. So I guess so. They share, no, that just looks crazy. They share all of them. All right, on to the next example. So we have this equation. We have this equation. This one will be, yes, well, this one's, it's actually in reverse this time. This one is the reddish one, or the red one, and this one is the blue one. So I converted this red one, if you can tell down here. So minus 5x divided by 4, I get y equals negative 5 over 4x plus 3. And if you can see, I graphed it. And if you can see over this one, I graphed it. If you can tell, these lines are parallel. So they never, ever, ever touch, which means they never share the same solution. So what we can basically say is that the slopes are the same, right? Negative 5 over 4? Negative 5 over 4? Cool. So the slopes are the same. But the y-intercepts, this one starts up here and goes like that. This one starts down here and goes like that. But the y-intercepts are different. Well, I guess I can make that better. Intercepts are different. So there is no shared point. There is no shared solution. If you prefer to write point, you can write point. Another way of saying this is there is no solution to the system of equations. All right, so like I said, they have the same y-intercept, and they share the same, but they share the same slope. So like I said, they have the same slope, so they both go down 5, right 4, down 5, right 4, down 5, right 4. This one does too, down 5, right 4, down 5, right 4. But they both start, so to speak, in different places. The y-intercepts are different, so they never touch, which means they don't ever share a common solution, which means there is no solution to the system of equations that works for both of them, right? So this would be no solution. And we'll put no common point. No common point. And that is it, finally. Thank you.